All right, let's take a look at systems of linear equations. Just to refresh your memory, I'm going to use this actually. System of linear equations is just a group of equations, linear equations actually. It could be a group of two or more. In this case, we're only going to be dealing with two equations at a time. A solution to a system of linear equations is where the graphs of the equations intersect. So it'll be an ordered pair. It'll look like something with an x and a y. And yeah, it's just where they intersect. Now, we could just graph each of these and then figure out where they intersect, but we're not going to be doing that for this lesson. All we're going to be doing is looking at a system of equations, and we're going to be given an ordered pair, and we're going to have to tell, okay, is this where the two graphs would meet, or in other words, is this a solution to the system of equations? So the system of equations is an ordered pair. If two graphs never intersect, then you don't have any solution. There is no solution. And if two graphs lie one on top of the other, like it's the same line, then you would say there are infinitely many solutions. But we're just going to be looking at an example, and it should be really, really simple. So let's see the example here. And we're going to be determining, so determine whether the ordered pair is a solution to the system of equations. And so the system that we're going to be given is going to be 3x minus y equals negative 3. And the other equation will be x minus 2y equals positive 4. So that is our system of equations. Remember, a system of equations is just a group of two or more equations. And we were also going to be given ordered pairs because determine whether the ordered pair is a solution or not. So we have to figure out, is this a solution to this system of equations? And then we'll do part B also, just to check another one. Is that a solution to the system of equations? I forgot my red pen. Hold on. So all we're going to do is plug in, this would be my x. Hopefully you can tell that that's a different color. X, this will be my y. And I'm just going to plug them in to both equations. Make sure you plug them into both equations. So really what I'll have is, from the first equation, 3 minus equals negative 3. And I'm plugging in, I'm checking part A right now. So I'm checking to see if this is a solution to this equation. Now, for this to be a solution for the system of equations, it has to work in both of them. And you'll see what I mean once I keep going. But I'm going to plug these in. So negative 2, negative 3. I plugged in the x for the x position, plugged in the y for the y position. Notice I have minus a negative. I still have to plug in that negative. So what do I get? I get negative 6 minus negative 3 equals negative 3. That's plus plus. Negative 6 plus 3. And this actually does give me negative 3. So this ordered pair satisfies this equation. Now I must check to see if it satisfies this equation. I have to check both. So I'll take the second equation, and I'm just writing parentheses for each of the variable slots. And then I'll plug in the same ordered pair. I'm checking the same ordered pair. So negative 2, negative 3 for the x and the y. So the x comes first and then the y. So negative 2, this would be plus, negative times a negative is positive, plus 6 equals 4. Negative 2 plus 6 is positive 4. And 4 equals 4. Since this ordered pair satisfied this equation, and this equation, we would say yes, I guess a solution. Because we're determining whether it's a solution or not. So for this part, that would be my answer. For part A, yes, that's a solution. Okay, now let's check for the second ordered pair. Is this a solution? Well, you should already know that it won't be, because there's only, if it's a linear equation or linear system of equations, you're going to have two lines, and two straight lines can't intersect at two different points, and this is a different point. But we're going to just plug it in and see what it looks like anyway. So part A is done. What about part B? Part B, I'm just going to do the exact same thing. 3, so the first equation, 3 blank minus blank equals -3. And then I'll plug in my x and my y. So 1 there, 6 there. 3 minus 6 equals -3. Well, 3 minus 6 is -3, so that does work out. But that just means this ordered pair lies somewhere on this line. It doesn't say that it lies on this line also. So let's check that part and see what happens. So blank minus 2 blank equals 4. I should say this is for A, this would be for B. And I plug in 1 for the x spot, so 1 minus 2 times 6. Let's see, that would be 1 minus 12 equals 4. 1 minus 12 is -11 equals 4. That is not true. So then we would say not a solution. Solution. So we have two answers, but hopefully it should make sense that if you get one of them and it is a solution, the other one's not going to be a solution, because they're different order pairs, and you can only have one place where they all intersect if they're just two lines like that. And that's all you're doing for this assignment. You're just plugging them in. If you get something that's true for both equations, then whatever you plugged in is a solution. Otherwise, both of them have to be correct for it to be a solution. Both of them have to make true statements. 4 equals 4 is true. -11 equals 4 is not true. And they both have to be true to be a solution. Otherwise, it's not a solution. And that's it.